When we're looking at the periodic table and looking at nuclear reactions, it's important to all have the same notation. And we'll use this notation here, where X represents the chemical symbol. Z is the atomic number. We've already seen that. Think to yourself, what is the atomic number? What does the atomic number represent? Remember, hydrogen had an atomic number of 1. Helium had an atomic number of 2. And so the atomic number is the number of protons. And then A is the atomic mass. The atomic mass is the number of nucleons. What is the atomic mass for, say, I don't know, hydrogen, which has 1 proton? How many nucleons does hydrogen have? Well, hydrogen also has a neutron, so it has 2 nucleons. It has 1 proton and 1 nucleon. So if I were to write this symbol for hydrogen, I would say that it has an atomic number of 1. H is the chemical symbol, and then it has an atomic mass of 2. It has 2 nucleons, 1 proton and 1 neutron. And so the number of neutrons, if I wanted to know the number of neutrons in hydrogen, I would say it has 2 minus 1. That's the number of nucleons, the number of protons, and so it would have 1 neutron. And so the number of neutrons is equal to A minus Z. Often books will not include Z in this notation, so they would say instead of H12, they would just say H with a 1 subscript. Here's another example. This is carbon 12. Can you tell me how many protons, how many neutrons, how many electrons this atom has? This is carbon 12, we would call it. So how many protons does it have? Protons is the atomic number. That's Z. If we go back, look up here, Z is this bottom number right here. So it has 6 protons. The number of neutrons that it has 12 minus 6. That is going to be A minus Z, which is equal to 6 neutrons. And then the number of electrons that it has we'll assume that it has 6 electrons. Okay? That's assuming that it's, that it's not ionized, that it's a electrically neutral atom. We'll also use Z in units of the fundamental unit of charge. So protons have a Z of plus 1e. Electrons, Z is minus 1e. Neutrons have a Z of 0. And then gamma rays, which aren't really particles at all, they have no mass. Or excuse me, no charge, no mass either, but no charge. So they also have a Z of 0 when we're talking about gamma rays. But again, gamma rays are not particles. Gamma rays are photons. They are little corpuscles of light, little pieces of light. We'll call them particles of light, but they don't have a mass or a charge.